Okay. Anyways, I've been going to code.com and yeah. Anyways, I've been coding. This is 120 and yeah. So that angle would be about 135. I just randomly guessing, and that fits it to go like that. You know what? That angle is 120. Let's just go with that. Wait. That is not 120. How is that 120? Let me see this again. They just... I have no idea what it's doing. Let's reduce the angle just to see how this affects. Oh, I get it. I'm turning like that. So take this out. See how it does like that. And it gets set up to do that. So let's just change it by 90 degrees to set up for the square. I was not paying attention to that at all. Anyways, there we go. So, the coding. For variable count 0, count is less than 3, count plus plus, so count is equal to 3. Move forward by 100 pixels. Turn right by 120 degrees. And then end the repeat and keep on going until 3. Turn right by 90 degrees. Which, notice how it's not in any repeat, so it only does that once. For variable count 2 equals 0, count 2 equals to 4. Anyways, that's just saying it's a different count by count 2. Count plus plus. Move forward by 100 pixels, turn left by 90 degrees. So that's it. Next puzzle. We're on stage 5 of this, because I started before this. Okay, let's make it a bit harder. See if we can draw these green glasses. Okay, green glasses. The squares are 100 pixels on each side, and they are 50 pixels apart. Don't forget to draw in green. Okay, because all of it's green, let's start out by green. That is not pure green. Where is pure green? I don't see any pure green, so let's just get the closest. So it's turning right. And then why am I doing this? Repeat block. Anyways, yeah, I wanted to program for a long time, and then someone brought up this website, so now I'm doing it. So that gets you around the square. You turn right at the end, so we need to turn right or left by 180 degrees outside of that block. So now we're facing this way. We can just go at 150 pixels. Remember that there are 50 pixels apart, so we need to get to that line. So move 150 because we want as least blocks as possible. Now put another repeat block, and we already are set up here, but we still need to turn, so we turn first before moving forward, and then after 4 times that should complete the puzzle. Let's hope this is the right green. And I accidentally didn't change this to left. I forgot we were on top of it. Notice that I didn't have to do that, but I did it anyways. Can I go back to change that? No, I cannot. Okay, figure this one out. What happens if you run this code or press run to try it, then repeat it enough times to complete the drawing. The drawing will be different every time. Okay, random code. Okay, we can move backwards apparently. Does it have to be those colors? Anyways, you can change how fast it goes. I tried the rapid speed before. Let's just show you how fast rapid speed is. Apparently we need, of course we do, we need the repeat block there. So insert all of this in the repeat block. There are 1, 2, 3, 4, 5, 6, 7, 8 ones, so change this to 8, and we should be good. That's how fast rapid speed is. Wait, let's go back, or not. I wanted to put the random color inside of it. Can you figure out what number to replace the question mark with to draw a circle? Repeat how many by 1 degree. Okay, now we're using these kinds of blocks. By the way, I did Scratch before, so all of this is easy for me. Anyways, now that you saw rapid speed, we're done with that. Let's turn it a little bit towards that because we're doing it this many times. Yeah, let's definitely go rapid speed. So now it's like a real pace thing, but it's doing 7. How did I write 0 lines of code? I didn't more than 0 that time. Variable count equals 0, counts 360, move forward 1 pixel, turn right 1 degree. Anyways, continue. You made it! Now, draw anything you want. Some fun ideas, a stick figure, snowflake, or spiral. Also, try the new set width block. Have fun. Okay, set width block. I'm guessing this is in pixels. 50. Move forward by. Okay, let's put these two together. Let's see what it does. I don't know if that was 100 or the set width block. Set color random.
Lesson 6 teaches algorithms and gets across how important it is to be as clear as possible. This lesson has two parts. The first uses tangrams, which are puzzle pieces that look like this. If you don't have tangrams, you or your students can cut them out by hand. Students will have to explain to a fellow classmate how to arrange tangrams in a specific pattern, but the second student isn't able to see what the original pattern is. In the second half of the activity, we ask students to figure out how many different ways they can fold a piece of paper to create 16 identical rectangles. Then you'll discuss how multiple solutions can lead to the same end result and why some solutions are better in certain situations.
And it is more than that. Let's try 60. Apparently that's exactly the right edge. You can see it's a bit more. Wait, Lisette, is that a 90-degree angle? I think it is. 90. And this is turn right. Yep, turn 90 right. I have no idea. Oh, it turns there, so it turns that direction. I thought just... Okay, here's the code you wrote to draw a single triangle. Can you add a repeat and turn block to make a pretty flower? Okay. A pretty flower. We only have 2 blocks and it said a turn. turn block and a repeat block. I know the repeat block goes inside the repeat block. Repeat block goes inside. Well, anyways, we need multiple color roses, so let's put the whole thing in. And then turn right goes outside of that. I'm not going to calculate that, and yes, it is indeed. And the degrees out of whatever. Here's the same code from the previous puzzle. Okay, keep on repeating. We're only on puzzle 4 and we repeated the same thing 3 times. Here's the same code from the previous puzzle, but turning only 36 degrees after drawing each triangle, and that's why there's so many petals. How many times does this need to repeat? Hint after. Okay. 10. Thirty-six goes into 360 10 times, so 10 gives you that. Oh, come on. We're repeating it again? Yep, we are. Here's the same code from the previous puzzle, but repeating the turn 36 times. How many degrees should it be? Why you keep on making me do this? Oops. What? Coding.
Oh, let me see it.
It's a program.
Oh, so it's a lot like that other thing, right? Like Sketch?
Scratch.
Scratch?
Yeah.
Cool. I'm glad you're doing that, Liam. That's really good.
Yep. for this to work, we need to do 20 because we also move an extra 20 there. So it seems like as we go along, it should be more than rabbit speed. Luckily, they included the scaling. Here's a solution to the previous puzzle. Can you add just 2 more blocks to complete the drawing? Yes, I can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 each side. So we don't need to put a repeat on that repeat. And then, just guessing by the problem, I should only need to add that one, but yep. I just wrote 2 lines of coding. Okay. There's a solution to the previous problem. How many degrees should you turn to complete the drawing? You probably need to guess a few times. Okay, it's nearly a bit less. Let's do 80. You can see how those are not the same thing. Guess a few times. I guess the first try. There's a solution to the previous puzzle. How many times should you repeat to draw the drawing? So, it has an extra side there. So go down like that, go back here, and then 1, 2, 3, 4, 5 extra times. Oh. But with just more layers. Let's do 75. 75. I know I'm not quick off, so that's why I jumped to the so those are nearly in line. So the second side is nearly in line with the first one. Just a tiny bit off. Why is this not fully rapid speed? It keeps on going off. things where it looks nearly like an actual circle, but it's not one. I got a trophy for a repeat time block. I just randomly get trophies. I don't know why I even get them. Okay, functions now. Stage 8, I have no idea how many stages there are. But anyways, in this lesson, students will make a sun catcher out of string, beads, and a special charm. The students will follow a series of repetitive, I just skipped that, steps, and be asked to identify certain sets of scales that are duplicated several times. Once those skills are defined, there will be codes from a main program. I'm doing the same thing I did in the I just not bring it up, and the whole beautiful process of creation will be recorded on a single sheet of paper. The final program will be geared toward the entire class, whatever the type of string, beads, and charms. To effectively allow this, students will need to abstract out the details of the specific materials and create a vague terms of an individual supplies. This use of placeholders is a wonderful introduction to variables. Okay. Unplugged active functions.
As you might know, a function is a really great way of defining a set of steps that you plan to use more than once. This activity takes that concept and uses it to help define steps to create a sun catcher with beads, string, and a special charm. You'll follow a series of special steps and then be asked to identify skills that are repeated several times. Once those skills are defined, they can be called from a main program, and the whole process is recorded on a single sheet of paper. This activity provides a wonderful introduction to variables, functions, and programming in general.
I'll probably not try any of these until I actually don't know the stuff. I do know variables, so... Oh. Hi, I'm a farmer, okay. Oh, video farmer intro.
In this stage, you're a farmer
who tell me if that doesn't remind you of someone like Yoda. Today, you are a farmer. Actually, it doesn't remind me of Yoda, but someone else. I can't think of his name right now, though. Anyways.
wants to get their field nice and flat to start planting crops. In each puzzle, she has to remove all the piles of dirt and fill in all of the holes. The new blocks remove one shovel full of dirt from a pile and fill one shovel full into a hole. The piles and holes are different sizes on the field, so you have to tell the farmer how many shovelfuls to use. Let's help this farmer out.
I didn't exactly understand that, but I know I'll get it. Hi, I'm a farmer. We need your help to flatten the field of my farm so it's ready for planting. Why are you flattening it if you're just about to unflatten it to plant seeds or whatever? Move me to the pile of dirt and use the remove block to remove it. Okay? Move one pile of dirt. It says one there, so probably that's why. So move 1, 2, 3. Am I supposed to move from there or move on top of it? We'll figure it out. So 1, 2, 3, 4. Let's try removing it from the top first. If that doesn't work, well, let's go again, removing it from that square. Okay, we'll move it from top. You just wrote 5 lines of code, all time total 180. Next, move me to the hole and fill it with 2 shovelfuls of dirt using the fill block. Move forward, fill 1, fill 1. I'm guessing that's how you do it. Yep, that's how you do it. And everything just turns flat. Why are we filling that tiny hole if there's trees all over the place, though? Congratulations, you completed Puzzle 2 and won a trophy. Sequence trophy. You just wrote 3 lines of code, all-time code, 183 show code. Let's see what the fill code is. Just fill blank. The blocks for your program can also be represented in JavaScript, the world's most widely adopted programming language. I forget if I mentioned that code part is in JavaScript. Move me to the pile of dirt and tell me how many shovelfuls to remove using as few blocks as possible. 10. Good thing we have the repeat block now. Repeat 10 times. Fill 1. Wait. Move 1. I'm keep on thinking she has a wheelbarrow with her and she's filling the wheelbarrow with the dirt and whatever you want to say is. And there's a ton of trees she needs to remove also. But everything turns clean, so that's good. You just wrote 3 lines of code, all-time total 183. Let's quickly check up on this. So it's been a viewer for about 11 minutes, so that's good that she's sticking along, he or she. Can you help me remove all 4 piles of dirt? Hint, use a repeat block if you can. Okay, we need to remove 1, go in 1 direction. So first comes remove 1. So let's turn, should I, no, remove actually doesn't come first. Move forward, remove 1, then turn left. Program. Then we'll be, I need to change that to 4. Actually,
While loops are pretty similar to what you do in everyday life. Imagine you are washing your car. You will keep scrubbing until it's clean. So while it's not clean, continue to scrub. So you're evaluating these things all the time. Hey there, we've got a new loop to help your farmer out. It's called a while loop. It's pretty simple actually. While a statement at the top is true, do something. For example, while there's a pile, remove 1 shovelful. Go ahead and give it a try with your farmer.
because we need to make sure that this happens again. We only use 5 of 9. So we quit the program. Yay! Let's see if there's any comments. No, there is not. And this viewer is apparently really likes this. All-time total 221. Anyways, thanks for being persistent, viewer. For variable count 0, count less than 2, count plus, while path forward, move forward, dig each time, because each time there's a hole there, turn left. I'm pretty sure if we dig while there's not one of these, like if we dig here, it'll just make a gap. I'm working late, so it's dark out. I can't tell how large the piles are, or we can. Now I don't have all the options I used to have. Wow, block. Move me along the field, and if there is a pile. Okay, now we have a if block. If there's a path ahead, move forward. If there is a pile, move 1. And now keep on repeating until there's no longer a pile, but we know we only need 1 because we can tell how many, but it will still work even if there wasn't a number. I'll keep on repeating, and we'll keep on with this. We'll keep on heading towards it until we hit the end of the road, and by the end of the road, we no longer need coding because there's no turns or anything. So the program, it detected it. It didn't detect it there, so it doesn't move anything. Each time there was a pile, she moved it. I'm pretty sure it's a she. Let's see. I don't. Move me. So, basically, I don't think this character's gender is undefined. We don't know if it's a boy or a girl. I'm pretty sure that's a dress, so I'm guessing girl. Who wears a dress while working on the field, though? Congratulations, you completed puzzle 10 and won 2 trophies. If block, I'm pretty sure I got that trophy before. And then wow block, you just wrote 4 lines of code, all time total. Let's look at the code. If is path forward, move forward. And then the if inside an if, so there's the second one. If pile present, dig. If pile present, block ends, and then while path forward block ends, and that's it. It's still dark outside, so again we have to do this. Move me along the field. If there's a pile, remove it, and if there is a hole filled in, and use the drop down menu of options. If block, while path ahead, you move forward. So basically we're just doing the same exact thing, but we also have to include to make sure there's no holes. Make sure you don't put the 2 if blocks in the same thing, because that'll just mess everything up, because it'll only try to detect if there's a hole when there's a pile on that place. So, because there's no place where there's both a pile and a hole, it'll never fill in the holes. Anyways, there we go. And she fixes the field again, and it all turns into green. Okay, we're done with that section, and we're going on to stage 10. I'm starting to get a little thirsty. I did not have a drink before this. And I don't mean drugs or anything. Well, alcohol. This is a class game. After introducing the idea of conditionals, if statements, and loops, Loops is basically what we were doing before. It keeps on doing it until it's not true. The class can practice together using the pre-written program, a deck of cards, and the luck of a draw. Anyways, I'll play this video. You will not hear me because I'm getting a drink. I'll be right back. Enjoy the video, guys.
This activity is called coding with cards, and it's great for any age. Like you learned with the if statements in earlier lessons during Blockly, if statements have a piece about them you have to evaluate to find out if it's true or false. That's the conditional, and they can be used in lots of different ways. And we take advantage of that by creating programs on paper that you run using a random draw of playing cards. You might have an if statement that says something like, if the card you draw is greater than 8, you get a point. Otherwise, your opponent gets a point. You can make it as simple or as complicated as you feel comfortable.
Okay guys, I'm back. I hope you liked the video. I'm just gonna continue without watching it because, oh, we're back on Plants vs. Zombies. Anyways, oh, apparently now he's the artist. Hello, me zombie artist. Me love drawing. Help me draw a square in special color. Important note, you have all the same blocks, but they now been arranged in categories. Okay. Math, I'm guessing. Loops, color, actions. Now everything's inside a variable block. Anyways, yeah. Turn right, move, and loops is all we'll need for this one. So first we need loop. It's already aligned, so we don't need the turn first. In fact, turning will mess it all up. Wait, 5? So these are considered blocks now, okay. I'm fine with that. And there we go. Welcome to using functions. Well, let you define new blocks. Try the new draw a square block found in the functions category to draw a small 5 by 50 by 50 square green square. So draw a square block. Okay. Draw a square length. I don't get why that's important. I know that So this thinks how many squares. We need 36 squares. Draw it. Says how much that is, and yeah, we already discovered that with the other artist guy, so with the circle and stuff. That goes really slow if you don't use the slider. You wrote 0 lines of code. Well, that's nice, just saying that's achievement like that. Anyways, let's show the code. For variable count 2, because this is the second variable, because apparently this is the first variable. So for variable count 2, that variable has 0. I'm pretty sure, yeah, this is how many variables there are in this square, and we have never used a variable so far, so each time until we get towards variables it'll have 0 there. And then this count, notice how it goes all the way down to there. So anyways, this count has 36, so it revolves 36 times. And then I'm pretty sure that basically says this is actually equal to it. I'm pretty sure. Anyways, pen color, color random. So basically it's a random color. Draw a square. For variable count, I'm not sure why those are. I'm pretty sure that means the computer doesn't use it, and it's just for someone else if you're looking to understand it. But whatever. For variable count 0, count again equals to 4. Move forward 100 pixels, turn right 90 degrees for each square. Notice that we haven't got out them. Now this distinguishes degrees for each and every square, how much they turn. This one's just for making the square. Each square has 90 degrees. So on to the next puzzle. Draw squares with sides of 50, 60, 70, 80, and 90 pixels. That's 5. Oh, multiple. So all of those. Yep. You'll need to use a draw square function 5 times. Anyways, because they change each time, and this is not, we can't really use a variable with the things we have right now. We can't use a repeat block, so we'll just have to use this 5 times. And once more, and I'll just say the length. Let's do this. The same colors, because with our amount of blocks we cannot say random each time. We'll have
I got my start in software working on Shrek, actually, a long, long time ago. You're taking these basic building blocks, loops and counters and algorithms, and you use that stuff every single day, and you gradually build it all up, and it just turns into this tool that an artist can take and then just run with it and just do really amazing things with it. Hey there! So, you did your squares. Good job. We're going to make it a little bit easier this time. We're going to do the same squares, only we're going to use something called a counter loop. The counter loop is just like a regular loop, but every time you loop around, you add a little bit of a number. So, you see your counter loop right here. It came from the loop section. And then you've got your draw square function that you've been using all along. So now, you just go into the variable section, you pull out that counter block, and you stick it into the length bit. So now what you've got, something that says count with counter from 50 to 90 using 10. Draw a square. So what that's going to do is it will first draw a square size 50, of size 50. Then it will add 10 to the counter, draw it again, and then as it loops around, it adds 10 each time, so you get squares of 50, 60, 70, 80, 90. So your zombie is going to be a master artist. Good job!
What? Okay. coding.
Okay. How was it going?
Good.
Do you want me to make you a sandwich?
Okay.
Do you want ham and cheese or chips again?
Okay. I was trying to do too much math in my head. I was doing 90 plus 90 plus 90, which I don't understand why it took me so long to get 270. Either way, I needed all of these, so I did not took the program on the left now. But I did took it a couple of times already. And he basically turns that way. Congratulations, he completed puzzle 9. He just wrote 11 lines of code, all time total 286 lines of code. And then, like I did showed you before, I have no idea what that all of this is. Can I get to continue? Hopefully this continues. Okay, now we do the same thing, but we also reduce the size, so we also need that continue strip thing. Oh yeah, which is called count with. Loop to do a family of snowmen with height of 110, 100, 90, 80, 70. Our snowmen are 60 pixels apart. I don't like this jump sequence because it's a little confusing. Because he turns that way, and then I have to turn him back that way, jump that way. Well, actually, it's not too confusing. I'd rather have it something else. So, no, it's not in functions, it's in loops. So I need this inside everything. The lowest. I need to start from the highest number because the highest one's first. 110 to 70 by -10. That should work. Then I take this one out and get the counter variable. And I need 2 turns. And also a jump. Is it? Yeah, jumps inside here. How many pixels? 60. I'm just gonna do this so in case I know how to count the X. Congratulations, you completed puzzle 10 and won a trophy counter block. And then there's the family. You just wrote 12 lines. Last one. Here's some code to try experimenting with different spirals. What happens if you change the turn amount or set a random color in the loop? Draw anything you like. By length pixels. I'm pretty sure we had length one. Ooh. I'm not gonna bother playing that with that now because I have to go soon. I'm gonna just make sure my mic's on. Some code to try experimenting with different. Draw snowman, draw a square. Let's do set random color within this loop. Move forward, turn right by 91 degrees. Let's see what this comes up with. That looks a whole lot better, and it looks 3D. It looks like a weird pyramid. Let's try that again. Yep, that zombie is an artist. Yep, definitely. Anyways, let's continue with that. I hope you liked that drawing that I programmed that zombie to do. Anyways, like I said, after that stage I have to go, so yeah. Next up, apparently, is songwriting. I have no idea what that has to do with this, but